Hello all, welcome back. In last video we discussed about calculation of Brownian motion for discrete steps. In this video we'll continue to explore Brownian motion calculation for continuous steps. But before that, let me reiterate what we learned in last video, and this is the continuation video for the last other two videos. I request to watch other two videos before continuing this one, and I'll provide those links in description. Let me write discrete formula first and reiterate what we learned in the last video. And this is the discrete formula where Wn of t equal to summation of I to 1 to k and zi square root of delta t. And we all know Wn of t is referring to the position at time t. And in last example I gave, in last video I gave one example, right? That we take the time interval from 0 to 1. Let's imagine this is the one. This is the time interval, and instead of we observe the move from 0 to 1, what we did, we divided into steps, n steps. Let's imagine this is 100. So after we divided by 100 steps, which is capital T by n equal to 1 by 100 equal to 0.01. This is what we get is called delta t. So delta t is 0.01 here. It means instead of we observe the move from 0 to 1, we are observing every minute step or move: 0.01, 0.02, 0.03. So each move, if you observe, this is 0.01, 0.01, etc. So what this k is referring to here is like, suppose my k is 0.3. Okay, I am observing particle movement or stock price movement at 0.3. It means to reach from 0 to 0.3, how many steps I have to take? This is not k, this is sorry, this is t, that is we are observing at 0.3. So to understand how many steps that we took from 0 to 0.3, those are 30 steps. If we divide 0.3 divided by our variance, this delta t also can be called as a variance. So once we have all these inputs or parameters, then we can calculate, or we can substitute the values in the formula to get the Brownian motion. Z we already know for discrete step, either plus or minus 1. This is the random walk, right? Either can take right step or left step. And since we already have a variance, then we can find out standard deviation, which is a square root of t, 0.01 of square root of t. In this case, let me calculate and provide you the proper number. And square root of 0.01 equal to 0.1. So once we have all the numbers, then we can insert in this formula to get the discrete value for Brownian motion. And the major difference for the continuous steps, calculation of Brownian motion for continuous steps, If you remember, in the last video we discussed that here what is n? Here is n is the steps that we are dividing the time interval, right? So instead of we take 100, it approaches, n approaches infinity. In our discrete example, we just took 100 steps, but in continuous it is infinity. So when my time interval divided by infinity, my delta t, this is the n, right? So delta t becomes closer and closer to 0. So after summation of all this random work, it becomes a continuous path, and that sum becomes a Brownian motion. Okay, so what, by central limit theorem, what we understand, the sum of many tiny random steps that scaled approximately, and it looks like a normal distribution, right? So we can write for the continuous w of t, it follows normal distribution with 0, and tt is a variance. Fine. And another detail that we need to understand, in our discrete example, here my zi is a random step, either plus or minus 1, right? In continuous, the zi is a continuous value. We can take that minus infinity to infinity, but since our point since we are calculating the position at point t, and it is following the normal distribution 0 t, right, which is a variance. So it means, uh, imagine, or let's take an example, our variance is a 1. Suppose, let me, w of t, and it is follows normal distribution 0 comma t, and in this case I'm saying 0 comma 1, my variance is 1. Let's imagine, uh, so as per normal distribution, we know 68% of the values that falls under plus or minus of square root of t, and 95% of the time then we'll get the variance plus or minus square root of plus or minus 2 square root of t, which is a 2 standard deviation, and 99% we know plus or minus 3 standard deviation, which is 3 of square root of t. So in our case t is a 1, right? So we know that for 95% we'll get roughly values between minus 2 to plus 2, and 99% minus 3 to plus 3. So I'll explain this with one example. I'll take both discrete values and continuous values to calculate Brownian motion. Let's take the time. T, capital T is a 1, which is the time interval we are observing from 0 to 1, and n for discrete I already explained above. N is equal to 100, which means I'm dividing this interval into the 100 steps. My delta t becomes 0.01, and step size, I know square root of delta t, which is the standard deviation, square root of 0.01. And in simple terms, to make you to understand what is a variance and a standard deviation, here variance is talking about the move from one point to the another point. This is what the variance 0.01 and 0.01, and every time it is a constant 0.01. This is what it is referring to. But whereas standard deviation is talking about, or it explains about, the move in y direction, not in x direction. It means like 0.01. So every step that we take, or we move from 0 to 0.1, 0.1, 0.01 to 0.02, that every move that we take, and what is the uh, position that we move in y direction is like, after we move 0.01, there is a probability of either go plus 1 or minus 1, right? So it means 0.1, there is a chance to move 0.1 up or minus 0.1. So standard deviation speaks about the y direction, and variance speaks about the x direction on a graph. Okay, so once we have variance, standard deviation, time, and number of steps, then it's easy to calculate the total steps that we took it, right, which is a k t by delta t, 0.3 by 0.01, which is a 30 steps. I guess earlier I explained that also. So overall we took 30 steps, and zi for discrete is a plus or minus 1, and zi for continuous is, I mean, any random number we take. Let's suppose take 2 in our example, okay, or anything we can, 3 or 4, anything we can take. This is the random number, or even minus 2 or minus 3, any number in continuous. But for discrete, this is the only step, either plus or minus 1. Now we'll try to calculate Brownian motion at a time t is equal to 0, and initially we know our value starts with a 0, even for continuous, even for discrete, both. So time 0.01 step, let's imagine our flip hits, or we took a right step, I mean random step, then z1 becomes plus 1, and to calculate our position, so we have to calculate dw of you know 0 equal to z1, this is the first step, right, and multiply with standard deviation, which is the square root of 1, so 1 into 0.01 and 0.1. And in last video I explained in graphical way also. Here also let me explain. So after we move 0.01, 02, 0.01, and our value, and we are at 0.1, here is our particle, or here is our stock. And if I take the time 0.02, and here random walk or flip or random walk example, let's example tail, or z2 is equal to minus 1, or left move. Okay, so to calculate this again, we do the same thing, like we calculate the w of you know 0.0 0.02, right, we are calculating this, and our z value is minus 1, and we know our standard deviation, which is square root of delta t, is 0.1. So now we are going to get minus 0.1. So after second step, which is 0.1, 0.01, and our step is 0.1, we are here. Let me change, we are here after first step, and after second step 0.02, and we got minus 0.1, so again we moved back here after 0.2 step. So that's how we calculate the steps for the discrete. And coming to the continuous, and instead of we take the 1 and we kept 2, 0.1, which is, let me calculate, 2, 0.1 equal to point. So This is how we calculate Brownian motion for discrete and continuous steps. The reason that we discussed this Brownian motion for the both continuous and the discrete to make you to understand where this component uh, been using this component that generally we get it in stochastic differential equation. In another video that I explained, stochastic differential equation is a to model that evolves over time with both deterministic and random, right, components. Let me write it down. So I hope that I'm clear with the Brownian motion for both discrete and continuous step. Now let's see the SDE, which is a stochastic differential equation. Like I mentioned, this is the mathematical equation d of xt, which is the combination of the both deterministic and random. And let's imagine this is the deterministic part, x of t dt, plus this is the random part, dwt. So this is the component that till now we discussed. This is called Brownian motion, right? So this entire part is called deterministic, and this entire part is called random or stochastic component. Okay, this deterministic part majorly speaking or explains about, or it simply is a ordinary differential equation which describes like how quantity changes over time with respect to a single variable. That is what the deterministic part. And coming to the random part, here we have a majorly three components inside the random part. One is the volatility, and another one is in our example that I'm going to explain, or using this stochastic differential equation to calculate the stock price changes. So in our stock price, okay, and another one is the dwt, which we discussed now. This is the Brownian motion. So these are the components that we can see it inside the stochastic differential equation. This part can also be called as a drift term, and this part can also be called as a diffusion term. Now we saw what are all components inside this formula, right? Let me rewrite and explain you with one of example. So suppose if you want to study the stock prices, so that is the reason instead of taking the yes, I am taking the yes. And this is the deterministic part or drift term that we already know is mean into stock price dt. It just ordinary differential equation which explains the how much changes happening uh, due to single variable change. And this is a random variable, right? In this random variable, random term that we already know, we have components like volatility, stock price, and dwt. These are the three components, right? Let's take an example. In our initial stock price, s of 0 is $100, okay, and the growth rate is interest rate. Suppose for 1 year we are get going to get 10% of interest, which is 0.1. And volatility, this volatility can be calculated in different ways. E- Example, if you have stock price for the last 1 year, either you can take the 1 year prices and find variance and standard deviation or volatility. This is the one way to calculate volatility. Another way, like we can take the Black-Scholes model to find out the implied volatility, and one more way, like we can use the Gauch model to find out the volatility. These are the different ways that we can use to find volatility. Let me write it down on my screen. What are the different ways we can take? First one is like we can take or observe the past historical stock prices and calculate volatility. And second one, we can use Black-Scholes model to find implied volatility. And third one, we can use Gauch model to find out the volatility. So for this simple example, I am just taking 20% of year, which is 0.2 as a volatility. And time step, this is crucial to calculate Brownian motion, right, that we already saw. So let's imagine we took 100 steps. So for 1 year we are observing, we have a data for the historical 1 year, and we are taking the 100 steps, so which is 0.01. So now first simulate step 1, and we are observing t02, t is equal to 0.01. Okay, and my stock price stock price at 0.01 equal to stock price plus stock price of at 0.0 plus my mu dt, which is a deterministic, and standard deviation, volatility stock price. This is the Brownian motion. So our initial price is 100, we already know, and our drift term or deterministic, which is mu into s of 0 to dt, right? And we already know our mu is growth rate 0.1, so 0.1 into 100 into number of steps that we took, 0.01, which is 0.1. So plus 0.1 plus, now let's calculate the diffusion term or random term to calculate that what all different components we should have, which is one volatility, stock price, and Brownian motion, right? So we already know our volatility is 0.2, and our stock price is 100 into, and we know our steps is, where is our steps is 0.01, which is a variance. Now into, let's take our z values randomly. I'm taking 0.5. So to calculate this whole number, 0.2 into 100 into square root of 0.01 into 0.5, which is equal to 1. So our new price is 100 plus, we already know, 0.01, sorry, 0.1 plus 1 here, plus 1. This component, entire component, we calculated here. Correct? This component we calculated here, and stock price, initial stock price is 100. So once we add all these all these three, then we'll get the new price, which is 101.1. This is how we calculate the stock price using this stochastic differential equation. So I hope I'm clear that clearly explain the definition of stochastic differential equation and what are all the components inside that we get it, and how we calculate the Brownian motion. So once we have all these terms, then we can calculate the new stock price. This is how we calculate the new stock price. In next video that I'm going to explain how we can calculate CVA and DVA, and where this stochastic differential equation helps us to calculate CVA and DVA. These are all we are going to discuss. That's it for this video. Thank you.